In the course of physics history, many quantities or concepts that were viewed as completely different came to be unified. And most of the time, this unification came to be of substantial importance, of great importance, I may say, to our understanding of the laws of physics or of the laws of nature. Albert Einstein's hope was to see all the fundamental forces of physics unified into a single theory. He attempted, and his attempt was unsuccessful. For over a century now, researchers and more particularly physicists all over the world have been attempting to describe all the forces of nature and how they interact into a single theory. The idea of unification in physics is important because it gives us a kind of holistic view of the laws governing our existence, of the laws governing the various phenomena that exist, thereby enabling us to combine small pieces of the puzzle together, which eventually or hopefully will lead us to a kind of ultimateness in some future in our understanding of the laws of nature. So let's look at a few examples of this. The first is the unification of motion and rest. They were unified thanks to the equivalence principle, which roughly states that there is no distinction that can be made between a body at rest and the same body moving at a uniform speed in a vacuum. Another example is the unification of electricity and magnetism. Well, Maxwell, the famous physicist, combined electricity and magnetism into a set of 4 equations that describe the propagation of all electromagnetic waves. Mass and energy, yeah, you surely guessed it, from Einstein's famous equation delta E equals delta mc squared, which basically tells us that the mass defect of an atom is associated to its binding energy. So, mass is actually an energy. Well, so far, you can move at the speed of light. Also, space and time, which were taken as 2 different aspects in Newtonian mechanics. But Einstein came up with his theory of relativity and combined these 2 quantities together. He combined the 3 dimensions of space with the 1 dimension of time into a 4-dimensional space-time. And as I always like quoting it, you need time to flow in space, but you still need space for time to flow. Yeah, well, looking at the case of the fundamental forces, there's some good reason to believe that they should be unifiable into a single theory. And the good news is that some progress has already been done towards this final step. First, the weak force can be combined with the electromagnetic force to the electroweak force, which in turn can be unified with the strong nuclear force to give us the grand unified theory. Now, physicists believe that this grand unified theory should be able to be unified with Einstein's theory of relativity, which describes gravitation, and this will give us the ultimate theory, the theory of quantum gravity, what physicists call famously the theory of everything. Will this theory of quantum gravity really be the end of unification, or will it be the last unification? Well, I leave this question up to you. Don't forget to like, share, and subscribe in order not to miss any upcoming video.